Hi, my name is Charles Matthews. I'm the architect with Grizzly Bear Architecture and Design. Today we're looking at the question of how to get architectural as-builts completed.
Today what we're talking about is how to get architectural as-builts completed. Let's go ahead and get started. What are as-built? I've heard the term as-built, and initially when I was young, I didn't understand exactly what it meant. And basically what it means is you're drawing something as built, as it has been built. So what a more technical definition of it is a documentation of the built or constructed items that are on the site. And so it includes anything that could be built, including buildings, but not just buildings. It could include awnings, it could include arbors, it could include sheds. It, it's basically any permitted or unpermitted structure that's on the site. Now, a site surveyor would have a little bit of a different job in that the site surveyor would come and he would map out, based on the plot lines of the property, the location of all of the, not just the building itself, but also location of plants, trees, other major types of structures. And of course, he's given a limit on that. On some pieces of property, you can have thousands of trees, as an example. So he would be given a limit of, say, anything that has a diameter of 6 inches or less or more, depending on what the individual constraints of the project are. So the site surveyor would do that kind of a job. And he would also get into topography, meaning the lay of the lands and the shape of the lands, the contours of the land. What the architect does, though, he focuses his attention on specifically the documentation of the built and constructed items on the site. And so the focus that he has is on the key relationships, establishing the key relationships between items that affect the architecture. So since the as-built, most of the time, as far as an architect's use of it, it's used as the basis for completing a design. However, as-builts can be used for documentation and inventory purposes, such as I at one point had gone to for as-built drawings, I had gone to a local utility, an electrical utility, and it was basically verifying the locations of all the walls and cubicles and uh, correcting the CAD drawings if they were incorrect, and then from there I'd also indicate the numbers that were on the locks and junction boxes, etc. And so that is an aspect of what as-builts can be used for as well. But basically what we're concerned about with as-builts is locating walls, windows and doors, protrusions, meaning anything that varies from the standard. If you look at a footprint of a building, a lot of them are rectangular, and then they have little parts of them that jut out. It's those jutting out parts that I'm calling protrusions. And for the parts that would, for lack of a better term, jut in, uh, I'll be calling those alcoves. Now, technically, the definition of it may not be exactly that, but for purposes of our discussion today, that's what we'll call them. And finally, heights, distances, quantities, angles. So if you have one object that is the same and it's repeated a number of times throughout the site, you do a basic analysis documenting one of them, and then you tell where each one of those pieces are throughout the whole site. You don't have to measure each one of them. Uh, However, at times there may be substantial variation between those, and so you'd have to measure it in that circumstance. Uh, when you're out on the field doing this, you just want to go ahead and make sure that you've gotten some key measurements of them and see uh, basically from those key measurements, are they roughly the same? And I say roughly the same. You can measure things with I like to use a laser measurer, and you can get within a 16th of an inch tolerance on those. And so there can be minor variations. There can be minor variations based on the temperature of the day and how it heats and expands metal, uh, as an example. So you're going to get minor variations, but you want to make sure that essentially if you're saying something is the same, that it is. Next, moving right along. If that's the definition of what as-built are, then the next question is, what are they used for? And so you'd want to use as-built in these kind of circumstances. I've already mentioned site documentation. It's a record of what is built, and I also mentioned for inventory purposes where you can extend uh, the scope of what you're documenting into fixtures, furnishing, and equipment in order to verify uh, whatever needs to be verified. You're checking out, you're seeing what's there, and you're documenting it. Many times, and I don't even know of a building that exists that I've been exposed to where the building construction is precisely what the architectural plans say they should be. And those buildings, it happens as a result of variations in material, and it's slight variations, but they are variations nonetheless. And so you have to realize, going from a construction document into the real world, there are at times going to be varying levels of skill, varying levels of quality of materials, and those kinds of things are going to shape the final product. You have to be aware of those kinds of things. And based on the tolerance that the individual client needs, there may be more of a need to police what's going on. As an example, if a client needs an exact and precise dimension of 3 feet, not 3 feet and a 16th of an inch, then that has to be communicated uh, to the general contractor, to the subs, and if it isn't, they're going to have to do it over again. And so it's important to understand what the toleration of minor discrepancies is, or what it needs to be. Now, you can require that someone exactly, absolutely precisely gets every dimension accurate and go out there with a tape measure and measure everything as it's being built and require that it meets those dimensions. Uh, and as an architect, if that were a part of my job, that's what I would be doing. Most of the time it isn't, though, and the reason is the client doesn't really need that level of accuracy, and they would have to pay significantly for it. Imagine going out there and having to measure and remeasure every board, every piece of sheetrock, etc. And if the architect is doing that, that's at a substantial hourly cost. And so that's why it's important that up front everybody knows what the tolerances are. So, and finally, we look at the other aspect of what drawings are used for. I also mentioned this. They are used as the basis for architectural drawings. They show what is existing, and if a person's doing a remodel on a house or a tenant improvement in a commercial structure, then an as-built drawing would be absolutely necessary. Here's the thing. When you're doing a space like a restaurant and a tenant improvement, type of a project. The thing that's driving the project getting done in the first place is how many people can you get to sit in there and eat the food at the same time. However, the number of people that are in there can also affect the size of the bathrooms and the number of fixtures that are in the bathrooms. And so the more people you have, the more bathroom fixtures you need, and the larger your bathroom has to be, thereby cutting into the space that could be used for sitting people and getting more revenue. And so it's super important for an architect to have accurate as-built drawings going into a building, going into a design situation. Now, the architect is entitled by way of the AIA contracts and also by way of the court system. And I should go ahead and add this. I'm not a lawyer, and I'm not in the realm of responsibility of giving legal counsel. So these are basically my opinions. Okay, so out of the way, what's important for us to remember is that although the architect is entitled to rely on drawings that are provided to him from the client, most of the time those client drawings are not accurate unless the client specifically hired a company to come out and complete as-built. It's just not they're just not accurate. A lot of times things would have been added over time, or maybe the drawings were done by hand and pencil from years ago, and as I mentioned before, all the minor eccentricities that come in with the construction of a building brings about changes in the floor plans. And so those are things that the architect would need to know in order to do the kind of drawings that are needed as far as the quality level is concerned. And in the example that I mentioned about the tenant improvement with the bathrooms, that can come down to, how many inches of space do you have available to you? And so everything counts at that point. And so if you don't have accurate drawings, then you are relying on something that's not reliable. So if you're relying on that in order to do your work is going to be off. You may make decisions that could cost the client thousands of dollars, and that all because you are relying on drawings that are not accurate. So let's keep on going. How are as-builts completed? Well, they're completed using measuring devices, where basically it's helpful to have two people doing as-builts, because one person can hold the tape measure if you're using a tape measure typically on the outside of a building. But one person can hold the tape measure and another person can hold the end, and things can go faster that way. Otherwise, if you have to do things like find rocks to hold things down with or that kind of thing, use duct tape, it can add up as far as time goes. So it's good to have two people out there doing the as-builts, but you would use measuring devices. I mentioned a laser earlier. There are also rolling devices that can measure, and the classical tape measure. There's also a yardstick, although I wouldn't typically use those. So you have these measuring devices, and you have a piece of paper, or you have a computer. With a computer, there are setups that can feed by way of Wi-Fi, a Wi-Fi connection. They'll feed from the laser into the computer so that you're documenting the building, and it's going directly into AutoCAD. Now those systems are they're really cool as far as that goes, and they are used in order to um, take one step out of the process, which is the transposing from hand-drawn items into the computer. And another strength of that system is that it allows a person to be able to see immediately if they are off in their measurements, comparing that to the drawings. Because when you're out there in the field, you're having to track hundreds, if not thousands, of different items, different pieces of data. And so in this little video, I'm telling you the major types of things that you would need to be taking into consideration as far as the overall strategy. But you have to realize that at times it's going to be really easy to make a mistake and leave something out. And it's therefore critical that you get the most important information down first, and then get enough information to where you can interpolate or go back and say, well, because say the outside of the building is 30 feet, I can't have anything on the inside of the building being more than 30 feet. So that's simple math, and it's totally based on living the world that we live in. But it's something that, when a drafter is in his cubicle or office space drafting, uh, and he's handed a whole set of pieces of paper that have a lot of different measurements on them, it could be that things are unclear, and so you have to make sure that those items are clear. And so now we look at the whole process of completing the drawings. We covered measuring devices using paper or a computer. Then you basically just walk around. You walk around the entire structure. You want to get overall dimensions, and we'll get into that in the next slide. Measuring devices that you can use are a tape measure. I already mentioned that. A laser-based system. It's a handheld laser. Basically, you hold it up against either the front face where the laser is going to emerge from, or from the back of the laser, and you can switch back and forth between the two. Just as a note, you want to make sure that if you switch to either the front or the back, you're used to going from the back, that you switch it back. Because everything can be off by the distance of the actual laser measure device if you don't switch the setting back. So a laser, extremely quick, extremely accurate. Then we have something called a point cloud method of measuring, and basically it's really cool. I like the concept. I've never done it myself, and I've never had the opportunity to use information that's been gathered this way. What a point cloud is basically someone sets up a box, and that box has lasers in it, and the box is about $60,000 or more. So that's why I haven't used it. But when you have it out in the field, and not having ever used it, I'm telling you conceptually the way that it works. You turn it on, it basically makes a 3D scan using lasers of the entire building and feeds it into its memory, so that you don't have to have someone going out and getting in a cherry picker or scaffolding and going up and measuring the distance from the ceiling, which is 3 stories high, down to the floor. You just shoot the whole building with a point cloud system. You go back, you put it into your 3D modeling program, your BIM, Building Information Modeling program, something like the Autodesk Revit. And in doing that, you can measure the distances and complete as-builts based on an extremely precise gathering of points. And so one thing you have to realize in a point cloud system is that there are literally tens of thousands of points that it has gathered information on. And so the whole thing there is you may have too much information, but usually you wouldn't spend the money or pay someone who has one of those $60,000 laser boxes to go out and shoot the building unless it was extremely vital that you had all the accurate measurements. But there are ways of taking that information, loading it into your BIM software, and being able to quickly make accurate as-builts. And touching on the paper or the computer, if you have a Wi-Fi connection between the laser and the computer drafting program, like I mentioned before, it can go fast, and it can go fast, but what you have, the benefit of that is you knock out the whole middleman, so to speak, in that you're not hand drafting and then later having to go back and draft it into the computer. It's already there. However, it can take a little longer to do that kind of a process. And so you have to weigh the cost as far as the cost of time, especially if the person doing it's not very skilled in completing that kind of a as-built. And an old traditional notepad where you would hand draw on it various sizes and locations of items and elements. So walking around, basically the technique that you should use, and I say should based on my experience, it's my opinion, but what you should do is you should go from outside to inside, larger areas to smaller areas, going from your ease of access to various locations, and then getting protrusions and alcoves. So the outside to inside, you're taking overall big picture measurements so that you can make sure that at least your building is going to fit within the accurately recorded exterior measurements. From there, you go from large areas to small areas. It takes more time in some ways to document the smaller areas, especially if there are a lot of walls. If there's a density in the collection of the walls that are in a certain space, that's going to take more time than, say, just holding up a laser and shooting it across the length of the space. And ease of access to various locations. People live in their houses, they work in their buildings, and so when they do that, they put stuff sometimes in hard to access locations. And I say hard to access, meaning it's hard to get to the wall surface. And so in that kind of a situation, what you do is you shoot from the object that's in your way, and then you measure the depth of that object in the same direction of the measurement that you've taken, so that you can make an addition just by adding the two distances together, you get the full length of the space. Now, it seems like that's a no-brainer, but it is something that you have to do as you're going around at times, because it may be impossible for you without moving stuff around or actually destroying property in order to get to the things you need to. And destroying property isn't a part of what you should be doing. So that's a big picture overview of how to get architectural as-builts completed. Now, certainly it involves walking around, it involves taking measurements, but the way that I talked about it as far as the order and the strategy, the tactics of getting the actual building done, from going from the larger to the smaller, And the smaller items also would include, the location of doors, windows, uh, posts of any sort, fence posts, light posts, those kinds of things. So you document it, uh, then you take it back to your office and you start doing the drafting. And that's a whole other picture, but that's the basics of how to get architectural as-built completed.
Hi, this is Charles Matthews. Just wanted to say thanks for watching the video. If you have any thoughts or comments, feel free to leave those below. Visit our website at grizzlybeararchitecture.com. This video is one in a series of videos that address various issues surrounding architecture and our practice of architecture and grizzly bear architecture. And if you have any thoughts or comments, I'd really appreciate those. Thanks.